Well, sorry. If you want to grab the slides yourself, or at least look at them, they are at that URL. That's, of course, as you see, the HTML, not the pod. This is actually all written in pod somewhere here. Right, so if you change it, you just type, if you're in the right directory, make. So this talk is on natural language processing in Perl. For the last 2 years, until the end of January, I worked at the University of Colorado doing computational pharmacology, which means analyzing the text of biomedical journal articles and trying to do things you can't do with Google. So NLP is natural language processing. It's not necessarily the same thing as computational linguistics. It just depends on who you're talking to, what they're talking about. And the thing that I think everybody probably knows is that using a computer to pretend it's as smart as a human in understanding text is not easy. When your compiler finds a syntax error, it blows up and you're expected to fix it. When a human finds a syntax error, he's supposed to figure out what you mean and keep going. And these are very distinct kinds of things. Doing things right is hard. I mean, the same word can be a completely different part of speech, even though, you know, it's the second word in that sentence and the second word in that sentence, but it's a completely different thing. Human language is tricky to make a computer figure out what it's doing. I once analyzed the OED's list of exceptional plural nouns, and there are about 2,500 irregulars of 400 different categories. So you can't just write ends in US, make it an end in I kind of rule, because you need 400 of those. And then without word sense disambiguation, without understanding it, you will never be able to figure out whether the word bases is the plural of base, or the plural of basis, or the singular of the verb base, right? Like he bases. It's hard stuff. This is my font is way too small for you guys back there. That's okay, most of the slides aren't that bad. I'm focusing this talk on something called morphological analysis. There are many other NLP topics. I can't click focus like that. The original, when we say parsing, we actually mean analyzing the syntax. I chose just stemming and lemmatization for this talk because it's small enough and focused enough that I might be able to say something in 17 minutes. But there's a lot to it. There's a lot of these things. So on CPAN, there are actually a bunch of NLP modules. There are quite a few people working in NLP in Perl. There's a fellow in Portugal, Alberto Simões, who's got his whole a whole department working on it. So if you've worked in the field before, you might recognize a few of the words on here, like the Genia tagger or the Stanford core. And sometimes there are Perl interfaces to these things, and that means you have to get their C or Java library and somehow interface to it. Sometimes it's simple enough that you can just write it from scratch in Perl. That doesn't happen very often, although people try it very often. So the problem is that a lot of the CPAN modules are, the nicest thing I can say about them is that they're not ready for prime time. They're really just toys. You can't use them for real work. So you got to look really hard at these things to see if they're, like lingua double colon sentence, you know, what does that do? Well, you might figure it out that it tries to split a paragraph or a body of text into sentences, but does it do it right? You know, there are many modules out there that think they can just use regular expressions to do that, and you can't. Don't think you have to stick in the lingua hierarchy. You can go outside. For example, for working on this last edition of the Camel, we used tach hyphen because their silly word processing software didn't understand English hyphenation rules, so I had to. And there's stuff in text too that might be useful. Okay, so the kind of morphological analysis we're going to be talking about here is the big long word for it. Where's the big long word? Affix removal conflation techniques. So let's say you just want to say how many times does the word canon appear in this text? Or how many times does the word, canonize appear in this text? Now it's a lot easier in English because English doesn't have much in the way of inflectional morphology. Conjugations and stuff. Imagine if you were in Spanish or Latin or something. You've got all these words that don't look like the word you're looking for, but they are that word. Canyon in canyons is probably referring to the same thing, although that's a... But they might be a noun and it might be a verb. And yes, canyon with a tilde is an English word, and it's not the same as canon. Then you get spelling variants. So when you're reading journal articles from the Lancet out of the UK, they use the SE forms instead of the ZE forms, and other silly things like that. Canonicities and Canon City are the same. Canyon City is in Colorado, never mind. So all this stuff we're talking about today, its goal is to chop off the ends of these strings to get to a common form. You can kind of do that with nouns. You can only go so far with it for verbs, like speak, spoke, spoken. Right? None of them, in fact, deal with prefixes. It's only suffixes. But when you are doing event detection and relation extraction, you actually care about prefixes sometimes as well, because to whatever is a negated event, or to something. So the whole goal is trying to find a citation form or the base version of it. Just chopping off the suffixes we'll call stemming, whereas actually, so when you stem something, you just go chomp, chomp, chop until you get a short word. It doesn't actually mean a word. So the result of stemming something is just the start of a word. It's context-free. Lemmatization, on the other hand, uses grammar and is context-sensitive. And it does reduce to a dictionary word. Dictionary words are funny things. Some people would say that there should just be one word for these first 5 entries that begin with the canyon or canyon, and that's from the OED. So you can't just throw away the tildes. And there are two kinds of canons. They're totally different nouns. And when it's not enough when you're doing sophisticated work or even half sophisticated work to conflate those two. But we'll be doing that this time around. So churches to church, examining to examine, just chopping things off. Again, the real, it's kind of like converting everything to lowercase to make them all look the same. And no one says affix removal conflation technique, although if you can figure out what those words mean, it does describe it better than stemming. They're context-free. There's no grammar. The kind of textbook work that everybody uses is the Porter stemmer, which was invented by Dr. Martin Porter at about 80 or 86. It was a long time ago. Since then, he has improved his work and re-released it, and it's now called the Snowball stemmer. It's still Dr. Porter's work, but you use the two different. Sometimes people say Porter stemmer when they mean the Snowball stemmer by Dr. Porter. They just do this kind of thing. They look at a suffix at the end and chomp it off. Oh, it's a little bit better than that, but not much. So the original Porter stemmer is available as a pure Perl module called Lingua::stem. It runs on anti-millennial versions of Perl. And it has an OO API, and you have to look these up to see what they actually return to get at them. If you do it this way, it's really slow. So what you want to do is feed a bunch of words at once to your stemmer and have it work on all of them at once. And hopefully not even give them back to you. Well, what good does that do? Because Perl does, you pass things by implicit reference. So it's got pointers to the original data. Obviously, just changing the length on those strings will be much faster than allocating more memory. And since we're chomping from the end, you just bump up you change the end of string pointer, it's fine. And that's how you'll get your best performance. The Snowball stemmer, which is the newer of the two by Dr. Porter, does require a C compiler, and it requires this completely modern version of Perl, 5.8. And it's generally an improved algorithm. It has a little bit better support for non-English. Notice here I specify a locale, and here a language and an encoding. I have no idea what happens if you lie about the encoding. I assume it just is horrible. Another stemmer, and one that's actually moving towards being a Lemmatizer, is the Lancaster stemmer. This is a recent one. The reason it's better, I'll show you examples, is that it has more rules about spelling exceptions, almost grammar rules. So you're moving into what lemmatizing does. There are other algorithms that are older that are not much used. People generally use the current Porter stemmer, which is Snowball, or this Lancaster one. See, I'm on slide 11. I'm just, for you guys taking notes, remember that you can pull these slides from that URL, training.perl.com, YAPC 2012/little NLP.html. And I'll put that up at the end too. So here's a good demonstration of the different kinds of things those three algorithms are going to pull out for you. Notice it doesn't take it down to necessarily to a dictionary headword. If you look at the Lancaster results, it changed succeeds into success. For the most part, especially the Porter stuff, it really works mostly on nouns, not verbs. Although here you see he's getting rid of the ED and the LY. But it does lots of stupid things. I guess I'll show you those later. Yeah, what matrices into metric. Probably not a good idea. I mean, for some purposes, any of these are fine. The important thing to do is to always use the same algorithm for when you store your words in a hash of these stems as when you're processing. It doesn't matter so much which one you do. You just have to be completely consistent. And of course you will, at 5 minutes to go, I'm not going to talk about the trade-off between precision and recall, but the more things turn into the same thing, the more when you look them up, you don't know which the original it was. So you have a good chance of finding it, but you don't know what you found. Lemmatizing is a smarter approach, requires much more work. It's not just nouns, it's also verbs. Finding the base form, the infinitive. It is a context. The best lemmatization is context sensitive because you pass in the part of speech for that word because you'll get totally different results on a different part of speech. So lemmatizers use both dictionary lookups and because human beings have this really annoying tendency to make up words that don't exist and expect you to know what they mean, which means you constantly encounter words that are not in the dictionary. So especially when you're doing biomedical text, you've got all these fancy long words that, now, when I first came to this, I thought lemmatizing would have been useful for that. I thought it's reducing it to the bound morphemes and splitting it all up into separate pieces, but that's not what they mean by this. That actually would be useful since even the scientists, usually when they create new words, these guys use Greek and Latin words to put them together. So instead of just dictionary lookups, you also need inflection rules. Now, they aren't very smart. If I had a stickum that ends in UM and I wanted a couple of those, STICKUM, you guys would know it would be stickums. No one would say sticka because there's no, I guess Greek can have a liquid ST, but there's no CK in the middle of a Greek or Latin word. So it must be an English type word, so you just add S. These things aren't quite that smart. They're much better when you have the tag. Taggers. A tagger is something that assigns a part of speech to each word. And the state of the art is about 95% accurate, which seems very good on a given word. So you pull up a word. Do I get the right answer? 1 in 20 times you don't. Well, you have to do that on every word of the sentence. So in fact, only about half the sentences are absolutely correct. Now that's not very good. It turns out you can't do good tagging without any syntax. You have to have context. So the best taggers, so some of the parsers, by which I mean syntactic analyzers, can also act as taggers and will give you both the parse and part of speech tags. So you use that stuff that comes back to you and you pass in the word and the part of speech and it'll uninflect it. So all these lemmatizers deal with inflectional morphology, noun and pronoun cases, singulars, plurals, conjugations, tenses, and inflecting adjectives, good, better, best. They don't do derivational morphology. They don't do adding ation on the end or adding IZE on the end. The one that I've worked with does, it does know about LY for adverbs. And there's this tool that we worked on at Colorado. It's called the Biolematizer. There's a big, long paper on it. I'll tell you in a second. And it's been trained on the specialist vocabulary from the National Library of Medicine's big, expensive corpus, bunch of words. So it's the best thing out there on biomedical text. It's actually an ugly bit of Java code, pile of Java code, and other things. So I didn't want to work in Java. I don't know why. So I wrote a Perl module called LinguaEN Biolematizer. It just starts up this slave Java thing. It talks to it on an Open2. When you get the slides, you can get the reference to the original journal paper. It is 29 pages long. If you can read it, then you're smarter than a computer. So you can call it as a CLI thing. You can call it procedurally, where you can pass a word without any context, or you can pass, that's a Penn tree bank tag. It's a part of speech. It's a discrete set of abbreviations. And it gives you back an answer. It's usually the right answer. So, oh, you'll never see that. Any chance of seeing that? Maybe. So, these are things that stemmers are crap at. There's irregulars, but just nouns. So we weren't able to use the existing stuff because none of these tools knew that bacteria and bacterium were the same thing. I have to make it smaller, don't I? I'm just trying to see where my stuff is here. What's the citation form for ours? Well, for some purposes, you just want it we, because it's a second person plural pronoun. And you don't care that it's in a genitive case. You just want it the simplest form. So you can get the Biolematizer if you want to do this kind of work, and it does much better. It's a lot slower than a stemmer, but it's still about 140,000 lemmatizations per second if you have enough memory. So I think that's like almost all the time I have. And then some. I'm 3 minutes late. Any questions about this? I'll put the, oh wait, sorry, one more slide. So the Biolematizer doesn't just return a word. It returns a whole bunch of interesting information. So for example, cast. It might be a noun or it might be a verb. There are two different tag sets that we return. Either the pen tags, and there's a much better, I don't like pen tags, they're stupid. There's a much better tag set that it can also return. So this will help with Wordsensedisambiguation. Line 2. Art. What kind of word is art? Well, it's either a simple noun or it's a verb in the second person. No, really. So what you do with the results is up to you. And there's the URL again. Questions? Does anybody? Yes?
What do you mean by amount of memory in terms of speed?
I mean that if you run it on, this is Java. If you run it on a 1 gigabyte machine, it will swap to that. We ran it on, I did pretty well on a 4 gigabyte machine, but all our timing tests were done on something with 128 gig.
Okay.
They have terabytes machines there that they run stuff on. Yes?
Have you somewhere published a broader list of recommendations for modules to use both within Perl and Liaison connections for NLP?
Yes. The question is there a list of modules worth bothering with? This is one list of them. I didn't put anything on here that I thought you should never ever look at. Who does NLP work here? Who's ever done NLP work? There's a fair number of you. Cool. Yes, I know I have to make them all go away. Other questions? There's no Unicode in this talk. Was there? Sometimes. Turns out that all the standard dictionaries are ASCII. All the tools think it's only ASCII. Very annoying.
How do you spell cañón?
Cañón.
Yeah.
Lo deja así.
Does it support other languages?
Yeah. The stemmers do. The stemmers do support other languages. I can't even remember my...
Especially for Biolematizer.
No, the Biolematizer runs off the National Library of Medicine's specialist vocabulary. So that one is specifically English. The stemmers are much simpler. That was dumb. I should have tried them on other languages. Because you can't just think of stem changing verbs in Italian or Spanish or French. You can't just stem down to, you know, je tiendrai. If you go down to tien instead of tenir, it doesn't work right. So the thing is, Snowball has very good international support. So if all you need is stemming, yes, you can do that. I don't know how well it does on Latin. I mean, I do know, and it's not very good. I think that part is toy. Any questions? I guess there's no session at noon in here, is there?
No, there isn't. So you can go over a little, but just remember to repeat the question, or the guys that are online.
Oh, there are guys online.
Wherever.
I always forget that you're not all here.
Even if we are.
Other questions? Yes.
Actually, how would it work, or how well does the body of words you have now, would that work against just a general English set?
I fed every single irregular LED. The question is, how well will the set that we're using with the biotext work on general English? I fed every exception in the OED to it.
And the results were?
Unbelievably better than things that did not have that fed into it. No, I built it. It uses the rules and the dictionary lookups from the OED. So,
By fed, you mean as source information, not as test.
right.
Could you get a little closer to the mic? I'm sorry.
Oh, I have a mic. I don't like mics. Okay, so yes, I fed the entire OED into it, not as training, more as training data, the test data. Although that's not quite what it is. But it's got all the OED's exceptions, so it should do, assuming it's words you can look up in the OED, it should do well. And if it's not, it falls back to detachment rules, inflection rules. It might, they probably would think the plural of stickum is sticka, unfortunately, but. Who's done NLP work not in English? ¿Quién ha hecho algo en cuanto a NLP en una lengua que no sea inglés. Okay.
I did a little bit in Chinese.
Oh, did you? Oh, that's very interesting. So just figure out where the words are is hard in Chinese. Yes. Word segmentation when you don't have white space. I told you this stuff is hard. And it's fun too. There's a bunch being done in Portuguese and even some in Brazilian. I don't know how many people are using it for the high throughput, large memory stuff that they use Java for. But it's easier to hire Java programmers than Perl programmers these days. Well, I have another talk in like an hour or something. And that one is 2 hours long, so I won't have to rush quite so much. Again, you can pull the slides from there if you'd like. At least the HTML. I'll arrange to put the pod up later. Okay. Ite missa est. It's done. Get out of here.